All right, guys, let's go ahead and look at Unit 7, Lesson 12. Think about it. Stacy went for a walk after school at a constant speed of 2.5 miles every hour. I'm going to underline that. Maybe important information for me. The equation 2.5h equals m represents the total number of miles she walked in h hours. So I'm going to go ahead and underline that as well. That's what it represents. Okay. First question, how many total miles did she walk if she walked for 3 hours? So first thing we need to do is figure out what's given to us. Well, let me annotate it first. They want to know how many total miles, which means I'm looking for H or M. Seems like I'm looking for M. As she walked in 3 hours. Cool. I'm going to start off by writing down the equation. 2.5H equals M. And the variables are defined for me, where M equals the total amount of miles and H equals hours. So what did they give us? They gave us hours. So I'm going to go ahead and substitute that 3 in for H. And I rewrite my equation as 2.5 times 3 is equal to M. Did I substitute the correct thing? Yes, because I'm looking for the total amount of miles, which means I'm looking for M. So side work will show 2.5 times 3, and I should come up with 7.5. So the total amount of miles in 3 hours should be 7.5. Okay, let's look at part B. Let me go ahead and recognize my answer. How many hours did she walk if she walked a total distance of 17.5 miles? So it looks like they're asking a similar question, but they're asking for something different. They want to know how many hours this time. Previous one, we wanted to know the miles. Part B, we want to know how many hours, which means something new might be substituted. So we were giving that there were 17.5 miles traveled. So we need to figure out the hours. Same equation, but we might deal with a different variable first. So what's given? Given is the amount of miles, and miles is represented by M. So I'm going to go ahead and substitute that in. 2.5H is equal to not M, but 17.5. How do I know that? Because that's the information I was given. Now we all are equipped with solving this kind of equation. If you need to, you can go ahead and draw your model. We know that the number being divided is 17.5, 2.5 H times. Agreed? Which means H should be equal to whatever 17.5 divided by 2.5 is. We know to multiply by 10 over 10, 175 over 25, because we shift the digit. Side work, and 25 goes into 175 7 times. So we know that H is equal to 7. So in part B, it would take 7 hours to travel 17.5 miles. Part A, it would take 3 hours to travel 7.5 miles. I'm going to go ahead and come up with a key point for you. We have 2 different variables here, and we know that we used a real world situation here. So we can use these 2 variables to solve real world problems with substitution. And the question is, which one do we actually substitute? We get that information from the context of the question. In part A, they gave us the amount of hours, so we had to find the total miles. In part B, they gave us the amount of miles, so we had to find the hours. So I'm going to go ahead and write this information in for you. When using 2 variable equations to solve real world problems, we must substitute the given value. I'm going to underline given for the matching variable. Oops, spelled matching wrong. What do they mean by this? When, whoops, when using two variable equations to solve real world problems, we must substitute the given value for the matching variable. For example, we substituted h for 3 in part A. That was the given variable. We matched it with h, which is hours. Another example, part B, we substituted 17.5 for m because that was the given variable. Let's move on to the interaction with new material. Michelle makes jewelry boxes containing drawers of equal size. I'm going to go ahead and underline equal size. The numbers of drawers in the boxes of drawers are shown. Inches. So what's happening here? So you may be thinking that someone is simply trying to figure out the size of the jewelry boxes. So what's our goal? Our goal is to determine the number of drawers in a jewelry box with a total volume of 22.5 cubic inches. What do we need to know? We need to know what the equation is to you. We need to know what the independent variable is, dependent variable. We need to know a bunch of things. And how do we use a key point to figure this out? Well, once we figure out what our equation is with our two variables, we can go ahead and substitute the correct one or the matching one to figure out what the result will be, okay? So let's get started. First, we need to go ahead and draw a table. You notice from a previous lesson, a table, a graph, and an equation can represent the same exact thing. Normally, our independent variable will be here, and our dependent variable will be here. We also know from a previous lesson that the x-axis has the independent variable, what represents it. So number of drawers is the independent variable, and total volume, which came from the y-axis, is the dependent variable. So let's look at the information they gave us. If I'm reading this graph correctly, it looks like this point is at 2,5. So if it's at 2,5, I'm going to say, I'm going to draw my little line here. I'm going to put a 2 and a 5. Some of you may be wondering, why did I put it there? Because I want to figure out what one is. So the next point right here says 3, 7.5. And the last point looks like it says 4, 9. How would I figure out what this number is here? Well, looks like they are a table full of ratios. So how you turn a 2 into a 1? You divide by 2, which means I do the same thing here. Divide by 2, I should have 2.5. That information is important to me. I need it. Now that I have my table, I can go ahead and create my equation. So we're going to say the dependent variable is represented by the variable v. We're going to say the number of drawers can be represented by the variable d. So let's use these two variables to create an equation. So v, which is a total volume, the dependent variable should be by itself, of course, is equal to, what do you think? Is it 2D? Is it 1D? Is it 2.5? Is it 5? Well, let's think about what the situation says. One drawer takes up the space of 2.5 cubic inches. okay? Which means each drawer takes up 2.5 cubic inches, which means I can go ahead and say that this is 2.5 times D. Cool, cool. So now that we have our table, our equation, and our graph, we can go ahead and start answering the question. Determine the number of drawers, okay? We're determining the variable D in a jewelry box with a total volume of 22.5 cubic inches. So what did they give us? They gave us the volume, they gave us V. So according to my key point, I gotta match it with the variable that it represents, which is V, and I substitute it. 22.5 is equal to 2.5 D. And we know at this point, our graph or our representation with the diagram is considered side work. So we know that 22.5 is being divided and 2.5 is being multiplied the amount of times. Now to do some side work, D is equal to 22.5 divided by 2.5, multiply both by 10. I get 225 divided by 25. So D is equal to, we have to do our long division. I'm pretty sure you all figured out that D is equal to 9. So now that we know when the volume is, I'm gonna say when the volume is 22.5 cubic inches, 9 drawers used. All right, guys, here is our result. Don't forget, when it comes to questions like this, you have to figure out what we need to create. What they gave us was a graph. What we created was a table. This is what they gave us. We created a table, and from the table, we created an equation, okay? So now that you have that information, you are equipped with answering these kinds of problems.